Welcome to my channel, and today we are going to be looking at a very beautiful question on a pulley system, and it's coming from a topic of simple machines, and it's me as usual, Eliezer Shilaba, and this is physics. So without wasting much of your time, let's dive in. We see what we can do with this question. Welcome to my channel, and today we are going to be answering this beautiful question, which is taken from the simple machines on a subtopic pulley systems. Okay, so we're going to be answering it together in this lesson, in this tutorial. Okay, so before you go anywhere, the very first thing is to understand the question. What is it asking you to do? Here we read it. We are told to say, what is the minimum effort required to raise the block? Alright, so to get the answer correct, this is what to do. The very first thing to remember is that for us to find the minimum effort required, we must use a formula which has an effort and the load, just like we've been given here. And in this pulley system, we are not given anything which has that, right? Yes, so we need to think. So in our case here, the only formula which has effort and load in them is the formula for mechanical advantage, and the mechanical advantage is not given here. So for us to find the minimum effort required to lift this block, we need to consider this pulley system as an ideal pulley system. Alright, and when we say it's ideal, we mean we neglect friction and any other energy losses. So the ideal mechanical advantage will be equal to the velocity ratio. That's what we mean. Okay, when we say it's ideal, meaning the velocity ratio is equal to ideal mechanical advantage. All right, now how do we find this ideal mechanical advantage? So we do that by simply following these steps here. All right, so the very first one is to ignore the number of pulleys you have, right? And this means that we are not going to be thinking in terms of the velocity ratio. We'll be thinking in terms of the ideal mechanical advantage. Then the second thing here is to count the number of rope sections supporting the moving pulleys, right? So what or how many are those ropes supporting the moving pulley? So we have got 1, 2, 3 and 4. So our ideal mechanical advantage now will be 4. So friends, you already know that the ideal mechanical advantage is given by the formula load over effort. So we have our load now here, and we have our ideal mechanical advantage. So all we need is to replace here and there to get our effort. So our 4 comes here and our 8,000 goes there, and here we are. We have now 4, which is equal to 8,000 Newton divided by effort, and we can get our effort by simply dividing 8,000 Newton by 4, which gives us 2,000 Newton as our minimum effort which is required to lift the block. Alright, so from there our answer is what? 2,000 Newton, which is B. So if you enjoyed this video, consider subscribing and sharing this video with your friends. Let me see you in the next one. God bless you.